Hey, this is Aaron Ruby and Will Ruby with Over My Head podcast number 3. Today we're going to do some live troubleshooting of my Timelapse Dolly, which is all inside this box and currently does not work. So here we go, Will.
Alright, here we go. Talk enough to get my face on camera. There I am.
That'll be how we start every
Yeah,
episode, is you talk
that's,
enough to get on camera just a little bit.
yeah, that's the plan.
All right, perfect. All right, so right now, the Timelapse Dolly, I'm actually pretty proud of how small this box is. The first Timelapse Dolly was in a box that was like 4 times this size.
hmm
But in my miniaturization, it's really crammed in there, so I'm gonna have to like carefully like pull it apart so I can get to all the little pieces. Before we do that, basically what's happening is I've got this side of the Timelapse Dolly is power. That's like a 12 volt in.
hmm
This is the 4 wires that go to the stepper motor. I've got a matching connector on the stepper wire.
Stepper motor box.
On the stepper motor side, that's right.
Yeah.
Because there's 2 coils inside of that stepper motor
hmm
that make the thing turn, so those have to be pretty specifically paired up.
Right.
And then this is just my big on-off switch, so I can like shut it off. That kills power to the entire system, so that the stepper motor will just release. If it's
Right.
not powered, it's not holding anything. But when I plug all that stuff in right now, nothing's happening, and nothing's really changed in this box. It's been sealed for the last, how long has it been since we used it?
Yeah, it's been a while.
It's been like almost a year, maybe, since we
Yeah.
went to Big Sur last. Um,
Yeah, I guess so.
so maybe it's just rotting from disuse, but
hmm
we're gonna figure this out.
Or something should go wrong.
The first thing I want to do is just verify that the Arduino is like responding to the computer. So let me plug it in,
hmm
and I've got a little bit of code that I can like flash onto the Arduino, um, which should give us like a little bit of an output that we can see. So let me
Right.
switch to my Arduino screen, and then we'll see if I can get that going. Looks like this screen. So you guys seeing this?
I am not seeing this. There it is.
So which part of it are you seeing?
I'm seeing your Arduino IDE.
Are you seeing
It's
all?
starting.
Are you seeing all of it, or are you seeing the whole code there? It's just like 8
Uh,
lines of code.
I'm seeing 8 lines of code in an enormous window.
Okay, great. All right, so it should say something like void setup, which is in every Arduino sketch. Serial begin, which lets us like start that um, serial monitor, which will allow us to like see any outputs that the Arduino is writing to that. And
Can
then all.
you can you like decrease the size of this window or something to make the text larger?
I
Yeah,
can try.
that's
Is that
that is
working better?
significantly better. Yeah.
Okay, sorry. I can't really see that window. Oh, I do see it now.
Cool.
Perfect. Okay, so the loop, all it's doing right now is reading whatever the potentiometer is saying, and it spits out that value to the serial print. So let's upload that sketch. And again, this is just verifying that the Arduino is responding, because right now we're just troubleshooting like what could possibly be wrong with this, and there's so many things that could go wrong at each step that we just have to run down the list. It says it's done uploading. Now let's do, it should be running that code now. So I'll
Mhm.
start the serial monitor. Okay, and let me switch windows there.
There it
Okay,
is.
so you should be seeing on the left side of the screen, that's 0. Right now the potentiometer is all the way down to 0 on the left. So as I crank it up, we see that the value's like increasing. Which is
Right.
this is really good news. Like this tells us that we're getting correct values out of the Arduino,
Mhm.
all the way from 0 to 1023. And you might have
Right.
noticed I have a map. I'm using like a map function, which I was getting. I don't know if I hooked up my potentiometer backwards or something, but I was getting like a negative. Uh, it was behaving backwards of what I thought it should be behaving. Like it was 1023 at its lowest point and 0 at its highest point. But right now it's working
Yeah.
awesome, which is good news. So let me switch back to camera for a moment here.
All right.
So what else is there? Like what else should we check?
Well, you know the Arduino works, but what is the actual symptom that you're seeing? Like you said,
Well,
it's not working, but
the stepper motor, when it's powered, it will like it'll tighten up. Like it won't be able to move unless it's intentionally being moved. Like when the coils are powered, you can't turn it freely.
right.
And that's what I was seeing, is that it was just spinning with like no power seemed to be going to the stepper motor.
Okay.
Which makes me think that the real cause is the stepper motor driver.
Mhm.
So let me see if I can get this out of here.
Even without the Arduino, the stepper motor driver should lock the motor when it's under power, right?
I don't know. I think that the step pin on the stepper motor driver, here, this is a mess, obviously,
Mhm.
but I think the step pin has to be at least in a up or down state, which I guess it would be. I could be
Yeah, I
wrong,
mean,
though.
it might be floating if it wasn't, but if it was floating, it would just randomly, intermittently trigger. It seems like.
Right. And that would probably be designed not to do that, because it seems like that's a good way to really burn out the stepper motor driver, is have it randomly trigger.
Well, it
So
just I mean, it just probably would read from the. Go ahead.
I'm just gonna say what you're seeing here on the my left, is it your right?
The right is the Arduino. The left is the Easy Driver.
All right. So on the right, you've got the Arduino. It's connected to the Easy Driver that's on the left, and the Easy Driver sends signals to the stepper motor. So Arduino controls the stepper motor driver, and the driver controls the motor itself. And
Right.
then this box at the top here is the giant relay that I'm using to trigger the camera.
Right. And why is that not just hooked directly to the Arduino? The camera, that
Um,
is.
yeah, I was worried about, I wasn't sure of the voltage of the pins inside of the camera, and I was worried about doing it directly that way. This kind of gives me like an electrical distance between the camera and all of this other stuff I'm doing.
Right.
Later I found out that the voltage on the camera pins is 3.3 volts, so it's well within like the ability of the Arduino to send that level of current.
Mhm.
And it probably could be. Do you think that's better than the alternative I'm thinking of doing is putting a transistor in place of the relay to
Right.
send signal to the transistor to basically the relay is an electronic light switch. Like you send it a signal and it flips its switch, which closes the circuit to the camera shutter and takes a picture.
Mhm.
And I could do the same thing with a transistor, sending a signal to one of the legs of the transistor, which would close the circuit on the other side.
Right. Yeah,
You
I
don't think
probably
that's
wouldn't.
necessary?
No, I wouldn't hook the camera up directly to the Arduino because that Arduino's got a 5-volt logic level, and that's enough different to be bad, depending on the tolerance. The point of the relay or the transistor is to electrically isolate those two things, so that the relay is triggered by a signal and allows another. It completes a different circuit,
Right.
like isolated from the input. So that's
Yeah,
why.
exactly right. So that's why I'm using this relay right now. One thing, relays, they're not they're not very fast. Like the actual switching time is significant, especially when
Right,
you're
because
dealing
it's
with
a mechanical throw.
right. So and it's also doesn't seem like it's very accurate. Like it might be slightly different each time,
Right.
um, like very slightly, but it seems to make a difference when you're taking pictures,
Hmm.
which is another great reason to use a tiny transistor instead of this giant relay.
Right.
It'd also be a lot easier to like hook together if it was a
Right.
smaller item.
Yeah, it could be on the breadboard. So just to loop back, what is it we're hoping to accomplish right now? What is the problem we're seeing? It's not powering the easy driver. Is
Yeah.
that a problem that has started happening since you hooked up the knob, or since you changed the code for the knob, or when did you start seeing this problem?
I think the knob was on there last time we used it.
I don't remember.
You know, maybe I added it after. But basically, I'm just not getting any response from the easy driver. So what I'd like to do is just plug it in to power. This is like it's a phone charger basically. It's a big battery brick, which I use as like a field battery for this thing. Works pretty well.
For the Arduino.
Yeah, it'll run the Arduino, and it'll actually run the stepper motor too.
Yeah.
You remember that, right?
I thought we still had the stepper motor on its own supply, but I don't remember.
That's when I made all these changes. That last trip we did, everything was running off of this orange brick battery,
Right. Mm-hmm.
and then I came home and was motivated to change the circuit so that the stepper motor had its own 12-volt source.
Right. Okay.
Is that right? Probably. Looking at this, I can see that the grounds are all tied together still.
Mm-hmm.
I don't know if you can see, but
Yeah, it's a little dark in the case.
so like kind of in the center of that image, you see two green wires next to this finger that's bouncing. Those are the grounds from both the Arduino and the stepper motor driver going to the same ground. We had some serious problems when that wasn't the case, when all the grounds weren't tied together.
Right, because the logic levels were not absolute to each other.
What does that... Do you know why that is? I still don't understand.
So the logic high and the logic low is in reference to ground, and ground is not an absolute property. It's like you can have like two you can have two systems with separate ground levels and the same voltage difference, but because they're not calibrated to each other, it's just the absolute voltage difference in either system that matters, not the absolute voltage. So it's just the distance, is my understanding. So like by tying the grounds together, you make the reference point the same, so then they can compare to each other, but without that reference point being the same, then there's no absolute comparison.
So you're saying the voltage is really like how different the positive side and the negative side are from each other.
Yeah, it's a differential.
So the 12-volt battery, the positive side should be 12 volts and the negative side should be 12 volts less than that.
Yeah. Yeah. So it's the difference that makes the current flow, yeah.
Mm-hmm. And then I think I've read someone describe it as like how far away from each other they are. Like that's how they describe the difference.
Right, yeah. Well, that makes sense, right? I mean, the difference is the distance between two values, so.
Yeah. All right, so I think what I need to do here is load the working time-lapse code onto the Arduino,
Okay.
plug in the motor, and plug in all the batteries, and see what we're getting, what behaviors we're getting. Let me go back to my Arduino window for a second.
Okay.
Just forgive me. I'm going to close extra Arduino windows so I don't get confused. Alright, so I've got the code that we used on our last trip, which was actually December 9th, 2013. That was the last time we went out, which is crazy.
It's been, well, not quite that long, not quite a year.
Yeah, not quite a year. Alright, so there's that code.
Give it a second. There it is.
We're an open source project, obviously.
Right, yeah.
So this is like heavily simplified code because what we were using was using that awesome library.
Yeah, the Easy Driver library.
Well, what was it called really? Because I think it was called...
It was like a servo... I don't remember the name of that.
Yeah, I think we talked about it on an earlier...
Acel Stepper was the name of that.
Excel Stepper, that's right.
ACCEL Stepper.
Yeah. Yeah, so they were doing... they were giving you the ability to have multiple motors, so if you're in like a CNC machine or something like that and you need to run multiple stepper motors, it's really awesome. Like you can use that library to send continuous movement to multiple things.
It also, as the name suggests, will accelerate instead of just pegging to a speed.
That's
so
true.
It will smooth the motion from a stop into movement.
Yeah. Yeah, which is really cool. So you can make like a gentle curve in your acceleration from stop to fast, which is pretty sweet. So let me load this code onto the Arduino here.
Well, let's just while we're here. So this doesn't do that. All this does is set up the pins to talk for the Arduino to talk to the stepper motor driver, and then it just toggles a pin low and toggles that pin high and does that over and over again. And then at a certain step, it triggers the relay to turn the camera on. Waits for the camera, and then just toggles the pin high-low for the stepper motor to move again. So by toggling that pin high-low, we get continuous movement from the stepper motor, or we should.
Yeah, this is good to look at this code because I lost one of my wire connections here.
Oh, there you go. That's maybe part of the problem.
From my relay to the Arduino, which wouldn't affect the movement, but would affect the ability to take pictures. And I can see that my shutter pin is pin 2. So I'm just going to reconnect that wire into my digital 2 port. Alright, so let me upload this. Somehow I've lost my serial ports. Oh. Gotta plug it in first.
That'll help.
This is all part of the learning process. Alright, so I'm uploading. Then I'm done. Cool. Okay, so I actually need to grab the motor. I'll be right back.
Alright.
Talk amongst yourself.
Yeah, so while Aaron is grabbing the motor, just to spend a little bit more time on this code, you'll remember, if you watched the first episode, the stepper motor can move either in a stop and take a picture, or it can move continuously. That's what that continuous variable refers to. So when you look down in the loop, it checks the current time. If we're not in continuous mode, and the current time is greater than the shutter interval, which is how long we wait between taking pictures, plus the last time we took a picture. So has it been long enough since we took a picture last? If it is, we stop, we take a picture. Otherwise, we just step the stepper motor. And it just loops that continuously until we turn it off. Are you back, Aaron? I can't see your video because all I can look at is this code. All right, so you can also see here the shutter delay, rather the shutter interval is, let's see, where is that used?
Hey, Will.
Hey, you're back.
So I just like spilled a big glass of water
Okay.
onto like a bunch of stuff.
Like stuff you should not have water on.
Yeah.
I take care of that.
Like, here, let me switch back to my camera here.
Okay. Oh,
Like this book of pictures of my wedding.
right, yeah. All those originals still exist, right?
Yeah. Hold on a second. I just I threw a pillow across the room accidentally
I see.
and knocked over a bunch of water.
That's fine.
This is live TV, guys.
It's all part of the drama.
Yeah, it's very exciting. So yeah, we can edit this out for the YouTube version, I guess.
Yeah, whatever you say. I was just talking about code.
Oh yeah, do you want that back up?
No, I think I said plenty. Anyone who's going to get value out of that code had it on screen long enough, and anyone who's not isn't going to get any farther because I talked about it, and it's not super helpful, is what I'm saying.
Well, in all the pandemonium, I should grab the motor for real now. You can see over here, this is the motor that pulls the dolly down the track. You see just the end of this dolly track?
I think the users can. I actually cannot. I have the little portraits of us in the way.
Here,
I don't know how to get rid of it. There we go. That's better.
Okay.
Okay.
All right. So let me plug in the Arduino and the power brick for the dolly.
Right.
So I'll just carefully put this back together. This is riveting, isn't it?
Yeah, we're in top form, right?
Yeah. I may have needed to assemble my visual aids before the show started.
Yeah. You needed to have one prepared earlier by your test.
Oh, I should have had one in the oven already, yeah.
Yeah.
Alright, so
let's, can you show the control box with the various wires in it?
Yeah.
Compared to earlier.
Right, so right now you've got just the USB plug.
Right, so that's into the Arduino.
That goes directly into the Arduino, and then the Arduino gets power from this power brick.
Right.
And then I need to just move it over here. This is the 12-volt battery. This provides the power to the motor itself, which actually does the work. Just place it over here.
These have both been hooked up, both these batteries before, right?
Yeah, none of this is new stuff.
Okay. I just was wondering if we should be expecting a fire.
Funny. Maybe. And then I'll just plug in the stepper motor wires into the control box too. Okay, so then let me turn on the Arduino power, and then I'll add the power for the stepper motor.
Okay.
So that's everything plugged in and turned on. Oh, and we're actually getting torque on this motor.
Is it in continuous mode? No, it's not. The code earlier. So is it turning and shooting and turning and shooting?
We'll have to wait for like 20 seconds, 30 seconds.
Right. So that's what I was talking about briefly. Probably it got cut, but at the end of my talking about the code section, the shutter interval, which is the time between pictures being taken, is very small. It's 400 milliseconds, I think, if I remember the code correctly. So we take a picture at nighttime for a very long time, 20 or 30 seconds, as Aaron alluded. And then we move a tiny, tiny amount. So that's what that 400 milliseconds is. It's how long we're moving between exposures. Is that correct, Aaron?
That's right. Let me pull that code up so I can verify that.
And has it been 20 or 30 seconds in?
This code that we just gave it is a 20-second delay. So basically, we're writing the shutter pin. Sorry, it's only 2. No, we should be seeing movement out of this. Let me pull the code back up for everyone to check out. No, what it doesn't give you is like your cursor, so you can't like highlight what you're looking at. Oh, yeah, it does. Okay, so what we're seeing here is this shutter length value is set to
a second.
1 second. That's 1,000 milliseconds. And you can also see this is the day mode for this code.
Right.
So what's happening is this shutter is being written high. So that's take a picture, wait this long, and then stop taking a picture. And then we've got 2 seconds at the end of that, so it can just like finish writing it to the camera card before it starts.
Yeah, it's just time for the camera to think, yeah.
Yeah, so like right now we're not getting that behavior.
What happens if you turn or you set continuous to true? Do we get continuous movement? You'll have to hook the Arduino back up.
Let's see. Where in the code do you want me to change?
Top line.
Boolean continuous equals true.
Yep.
And then where is that even being referenced in the rest of the code?
It prevents the camera from triggering and stopping the movement.
I see.
It's that if not continuous.
Right. Okay, cool. Yeah, so let me plug in the Arduino and I'll just upload this code. Alright, we're uploading. We're uploading. And we're uploading.
Have you reset your serial port? It looks like it's CU USB modem 1411 again.
Right.
Is that right?
Yeah, so here, let me just... Oh, I think it's all working, Will.
I do hear it moving.
Yeah, so let me switch back. So what we just had right there is that the upload didn't work because the Arduino wasn't plugged in correctly. Like it wasn't all the way plugged in to the USB. Right now the Arduino is running off my computer, which is a little scary. Let me turn this off. But you can see now that the stepper, like the stepper motor, is moving in line with that code. We've got
the original version without continuous.
Right, that hasn't been uploaded yet.
Yeah.
So if you would just stay on me for a second. Can you hear that over the microphone?
I heard it the first couple of times. I haven't heard it since maybe back away.
Mic perspective.
Yeah, we can hear that.
So you're hearing that, right?
Yep.
It doesn't sound healthy, though.
Healthy.
I think there's just too much tension on the string is all.
Do you have it hooked to the Dolly right now?
Dolly's down there, yeah, it's pulling on it. So yeah, it does seem like it's working as expected right now.
So that's interesting that it would work on your laptop and not on the power brick. Is that power brick charged?
Yeah, so I've got full power on this. So let me Let me disconnect it and see if
Were you in the 1 amp or the 2 amp? That particular power brick has a high current and a low current.
Right, you're right. So, yeah, you can see the center USB is like a 2.
It's a 1 amp in the middle and then a 2.1 amp on the right edge.
That's correct. So I'm going to
It's for charging nondescript generic tablets.
like iPads.
Hypothetically, yeah.
All right, so I've got it plugged into the 1.
Mm-hmm.
It's drawing power.
Oh, yeah.
And now it's running just fine. It's quite happy.
So that's interesting. So one thing I noticed that we did just now is when we initially hooked up, we had the stepper motor off. We powered the Arduino, and then we began. That's it. That's totally it. I know why. So in setup in the Arduino, there's a line where you set the direction pin.
Should I go back
the
to the
easy
code?
driver? Yeah.
All right, so we're looking at this code. What did you say?
Right. So what I'm thinking, and the more I'm thinking about it, the less sure I am, but in setup, that block of code only runs once, and it runs once when the Arduino is turned on. So when we first hooked up, we turned on the Arduino, and the easy driver wasn't on, and then later we turned the easy driver on. These
right.
times where it's been working, the easy driver was on, and the Arduino was power cycled by virtue of being unplugged and replugged.
Sure.
So the important thing I think that we're missing when we have the Arduino turned on before the easy driver is turned on is we set the direction pin, which is a configuration, like we're configuring the easy driver to tell it which way we want it to turn, right?
Right. Yeah, so the dir pin, in our code here, you can see that it's labeled dir pin, it's pin 8, and then pin mode, dir pin output, and then we're writing to that pin,
and we're
dir
setting
pin
it
high.
And now the only reason the reason I'm doubting this theory now that I had all of this said is that that should just stay high. We never set it low, so it shouldn't ever come down. But I bet you if you unhook the easy driver, plug in the Arduino, and then turn the easy driver on, I bet it won't run. And I bet the reverse will work if you have the easy driver on and then you turn on the Arduino.
All right, so let's switch back to the camera. We'll see if that's true. We're going to test this theory, so
yeah.
See how silly we sound. So what do you need me to do? You need me to turn off power to the stepper motor?
Turn them both off.
Okay, so let me do the stepper first. You can see that this becomes free to spin because there's no power to it.
Right.
That's just by virtue of being disconnected at this big red power switch. I don't know if you can see that.
Yep.
It's buried at the bottom there. And then now the Arduino is disconnected. So what do you want?
All right, so now plug in the Arduino. This shouldn't work. So plug in the Arduino.
All right, so power to the Arduino.
Contact.
And then lights on, so we know there's power. And I can see there's LEDs on the Arduino. Okay.
Okay. And then turn on the easy driver.
Okay. So that's this red button.
And what I expect should happen is it should hold and not move.
No, it looks like we're getting the correct movement. Which is good.
Oh, yeah.
We want the movement.
Right. So what happened that first time that, I mean, it was cold out of the box, and you didn't completely disconnect. Did you power the Arduino before you hooked the easy driver to the control box? You didn't.
I think I did originally, right?
So the Arduino was on, and then you plugged the easy driver in?
Well, I didn't plug it in because you're not supposed to disconnect power to the drivers.
No, not power-wise, but the control junction. Was that connected before you powered either? The white.
Oh no! I would have to look at the tape, but the correct thing to do would be to plug in everything with no power, so that
Right.
there wasn't any current flowing
Yeah, I think that's what you
during a
did.
disconnect.
Yeah, I think that's what you did. I'm just asking because I'm trying to understand why it wouldn't have worked that first time.
Right.
Okay, so regardless, we have it working now intermittently. You want to get that knob integrated in somehow. So let's look at the code. Let's talk about that.
Oh man. Okay, this is exciting.
So the things we need to do on a high level, we need to configure the pins for the knob as inputs so we can read those values. We need to read a value from the knob in the loop. We need to check that value against some arbitrary threshold that's related to the behavior you want. Oh, hey, I'm seeing myself. This is horrifying.
Sorry.
And then
recursive.
And then we need to, based on that value, either set the speed to something that you want, or we need to just set to continuous mode. So that's what the knob is going to do. If it's at a low enough setting, it's going to run continuously. If it's at a slightly higher setting, it's just going to map directly to how long the shutter is, right? That's the value that's going to get mapped to it?
No. What my plan was to use that value to set the speed of the dolly traveling.
Is that true? I thought the whole point of this exercise was that we would no longer have to change night mode, day mode, and that's shutter speed.
Right. So my thought was, okay, let me come back. Whoa, this is crazy. I look like I've been fighting a war. This is funny. My thought was the potentiometer gives us from 0 to 1023.
Right.
So if we set a stop in the middle of that, so I was thinking 0 to 20, so basically all the way down, the dolly's in night mode, and then 20 to 1023, we map that value to a speed ramp for the dolly speed. So it's like night mode is all the way down, and then once you start turning that knob, it goes into a continuous mode at a faster and faster rate.
Okay. All right, we can do that. So can we get the code up?
Yep.
Oh, very good.
Okay, so what you've got here on the left is the potentiometer reading code that we just played with earlier.
Okay.
In the center is the code that we just started based on code that we know works from last December. And then on the right is an attempt I made at doing this implementation a month ago.
Okay.
So that might be helpful.
Okay. So if it's less than 20, it's in the take pictures mode. And if it's over 20, then the knob just maps to the speed, right?
That was the idea, yep.
Okay.
So my thought was to do that with a couple if statements, or an if-then statement.
So basically what we'll do is in the code in the center, we can replace continuous with, so first of all, let's get that int potval equals analog read A5 and potval map copied over. We need those two lines.
So this is the start of the loop. It'll check the potentiometer.
Right. Okay, so we have that. So now, instead of if it's not continuous, we can just check against potval. So yep, get rid of that, and then if potval is less than 20. Right, okay, so that does make sense. Then down below that block, just above the step pin digital writes.
So pass this if statement?
Yep. We need to, if it's less than 20, set stepper delay to our fixed values. So write another if statement. And if pop val is less than 20, close that out. New line. It's very interesting. And then let's make a, so go up a couple of lines. Type in int space loop stepper delay or something.
Say loop stepper delay?
Yeah, because we already have a value called stepper delay. There you go. And then set that equal to stepper delay. So what this is doing is it's setting a variable in our loop equal to the global stepper delay variable. Then if down in this if statement, turn the make it a if pop val is greater than 20. So now if the knob is over 20, we're going to modify that stepper delay value, that loop stepper delay value. So go ahead and loop stepper delay. Loop, not the global one.
Say that again?
Do the loop one, not the global one.
Oh, sorry, loop stepper delay.
Yep.
Duh.
Capital S, yeah. So let's see. We have 20 to 1044. A larger stepper delay is a slower speed.
Yeah, that's right.
So I would just set it to pop val plus 976.
Based on what?
So 1024 plus 976 equals 2000, which is our
current speed.
Yeah, actually, instead of 976, make it stepper delay minus 1024. So you add the stepper delay plus, or yeah, minus the max size. And then close that if statement. And then change both of the stepper delays down below there in the delay microsecond calls to loop stepper delay. All right, and I think we can give that a try.
Seriously?
Yeah.
You feel like pop val is going to map correctly doing this?
Maybe. We'll see.
Oh my goodness. Okay. Let's upload it.
So this is going to cap out at a max speed of well, let me see. We want it to be the max value. Oh, it's going to be backwards, I think.
Should we still test it?
Yeah, why not?
Okay. This is drama. Hold on, let me detangle the dolly from the track. We made a very long dolly track.
Yeah.
By we, I mean I did.
I was willing to accept blame.
Most of the commercial dolly tracks are significantly shorter than this. Like 2 feet is a very common length.
We should just do 2000 minus pop val, I think, actually, on the loop stepper delay in the if statement.
So the bigger pop val is the
it's the inverse of speed. Rather, stepper delay is the inverse of speed. So the smaller that number is, the faster it goes. So the larger pop val is, the smaller stepper delay is, the faster it goes.
All right, say that again. So stepper delay minus.
Just pop val, or yeah, stepper delay minus pop val.
So loop stepper delay equals stepper delay minus pop val.
Yep. Yeah. So then at 21, right, your speed is 2000 minus 21. And at 1024, your speed is, well, basically, your speed is 1 over stepper delay.
Yeah.
So yeah, I think that makes sense.
All right, so we're going to upload this, and we'll see stepper delay is not declared in scope.
Lowercase s.
That's why we love modern coding thingies. All right, so it's uploaded. I'm going to disconnect it from the computer. I'm going to connect it to its power. Let me switch my camera back here. Whoa. I love that. Okay, so we're going to test this code live.
Okay.
Okay, so there's the motor. All right, so what did we decide our power-up order?
I would turn the easy driver on and then the Arduino.
Easy drivers on. That's confirmed by torque on the spool. And then I'm turning on the battery pack for the Arduino.
Alright.
So
and where is the knob right now? The knob is probably not at 0.
So knob is at 0 now. And it's
so it should step every second. Alright, so turn it slightly, and it should be continuous at about the right speed.
I am amazed by you right now, Will. So that's about 20, I'd say. And it's continuous, but slow, which is perfect.
So then turn it more.
Cranking it up.
That is a great noise through the mic, too. It sounds like an alien spaceship.
So its speed, I'd say, is like an inch a second, 2 inches a second.
So do you want it to cap out at a higher speed?
Whoa, and it just stopped.
Stopped completely.
Yeah, there's still torque, but it's not continuing. I wonder if the Arduino shut off. Looks like the Arduino lost power.
That's weird.
It does weird. Because the stepper motor still had power because it didn't like release. I'm gonna need to stop this. Stop. Okay. Great.
So do you need it to go faster at the high end?
Yeah, I would like it to go a bit faster.
Okay.
That speed is really nice, but if it's somewhere in the middle, then that'd be fine.
Right. Okay.
That's
so
slick.
What we should do.
That's some slick little coding.
We'll do another map, I think is what we'll do. So we'll map between 20 and 1024 to 0 and 1500 or 1750 or something.
Okay.
Because we can't make the shutter delay 0.
Sure.
But
okay, so we're back to the code here. You want to do a second map on pot val?
Yeah. So inside of that, if pot val is greater than 20,
yeah.
Let's map to a new variable. It doesn't need to be pot. It can be pot val. That's fine. We don't use pot val again. So, and then do map pot val, and we're gonna map it from 20 to 1024. No, because it's already inverted, so we don't need to do that again.
Okay, great.
So do 20 to 1024, or 1023. And then we'll map that from 0 to 1750.
So that's going to give us a slightly higher, well, like 50% higher top end.
Yes, but we can't take it all the way down. What we should really do is take it from 0 to, like, some percentage of stepper delay. So then if we change stepper delay, it's still accurate. So make it, instead of 1750, do stepper delay times, I don't know, 0.8 or something. Well, it might not like that because it's not an int. We'll probably have to do that outside. So go up a line. Declare int equals, or like a new variable, name it like stepper delay % or something. Name it whatever you like. Delay % would be catchy. And then that equals some fraction of stepper delay. You might have to have a leading 0 on that. I'm not sure. Lowercase s. I'm a syntax tool. And then round that.
How do I do that?
I think you can just preface it with the word round in Arduino land.
And does that take any input?
It takes that number.
And rounds
So
it to
that
what?
turns
To an integer?
to the nearest int value.
Oh, that's
yeah.
sweet. Okay.
And then we use delay % in that as the last argument in pop val's map there. And get rid of that other paren too. There you go.
Great.
So check that, see if we made any syntax errors. Looks like we're good.
It does look pretty good.
All right. Yeah, let's give that a try.
So I've got to plug the Arduino in. I'm going to upload. Okay, and I'm switching off that.
Mm-hmm.
Okay, so stepper motor power is off, Arduino logic power is plugged in, stepper's on, torque is good, and then Arduino power.
Okay, and is the knob all the way down?
Nope.
No. Okay, so this is all the way down, right? So it should move every second.
And it seems to be.
Okay. So let's go ahead and try to play with the range a little bit.
Okay, so that's the bottom end.
Okay.
And here it is going higher and higher.
Mm-hmm. That's a crazy noise.
I would say that's like 50% faster, probably.
That's about right.
The Arduino seems like it's losing power about here in the run.
You're not knocking the cable at all. Is the
really
brick
weird.
turning off? The power brick
Well,
you're
like,
using?
the power brick should. It's a smart brick, which hurts us in this case. It should.
It
As long as
turns
it's reading a
itself off.
draw, it should keep going.
Yeah, maybe we have to hook a phone to it to also draw power. Maybe the Arduino doesn't draw enough amps. What port are you plugged into? The 2 amp or the 1 amp?
Small 1 amp.
Yeah.
So it should have a lower threshold, I think.
Yeah.
Also, we used this successfully in the field before, right?
But it was drawing. It was
a
powering the
stepper
motor
too.
too.
Yeah.
Yep.
Maybe that's it. Maybe it doesn't know.
Do you have any dumb power bricks? Like batteries into a USB?
Yeah, what I
thing?
do have is those. I have like I have something else I could use.
Yeah.
Something that I stick like AA batteries into.
Right.
Yeah, that'd probably work. I'm sure that's not smart.
But I have no idea how long an episode this is now.
This is long.
Yeah. Well, it's probably been about an hour of since we started recording, but we've had so many flubs.
Yeah.
So maybe we're at like 4 minutes.
Yeah, so I think that's a good place to stop, though. Like, we've successfully got the thing moving again, which is a huge part of it. And then...
Right, and I think we've got that knob mapped in. Maybe to wrap up, let's look at what you had as to what compared to what we have now, just to have a look.
Okay, hold on.
Just to leave on some sort of summary note.
All right, so I've got to open that old sketch.
I think it's the one on the right, isn't it?
That's close to it, but what I was using was this one.
Oh no, I was going to compare it to your knob one. I wanted to see how the knob one differed.
Oh, to the one that didn't work, you mean?
Yeah.
All right. So what I was trying to do was, if pop val is less than 20, a bunch of other stuff. There's extra code in here that doesn't make any sense, and then so that's like the 2 second. Every 2 seconds it moves a little bit. So for night mode, and then day mode was supposed to be if it's greater than or equal to 20. I was trying to map the pop val to a big number, 5,100. And then using that for nothing.
No, you're using it to move the stepper motor.
I'd created a stepper delay day and a stepper delay night to hold different
You're modifying, yeah.
movement numbers.
Yeah, so we kept in the middle version, the new version we did today, we kept the motor drive outside of that conditional. So the motor drive is always happening, every run of the loop, from the same code. And the only thing we're ever modifying about it is those delays between the pin toggle, which is what sets the speed.
Yeah. Yeah, I think my superpower is writing code that runs into a dead end and then won't continue the loop.
Yeah, just looking at your code just now briefly, it didn't seem like obviously wrong, but you were saying it wasn't doing anything. So.
I don't think it was doing anything. And this code is much more elegant to look at, so I'd say...
Oh, it's very important. I did go to art school.
Very successful. Cool. So that wraps up a very hands-on episode of Over My Head, and you can see where the title comes from.
Cool.
We're
doing our best with what we have.
The good news is we'll have a working stepper motor or Timelapse Dolly for this trip with Greg, which is huge.
Yeah. And the viewers don't know this, but my camera was sent out for repairs. It has finally returned. So we will also have that for when we go out with Greg. So that's good too.
That's fantastic. Yeah, and then the other thing that we could check maybe next week would be make sure it's actually triggering the camera correctly. Right now it's hooked up with a relay, and I'd really love to
Did you hear the relay firing?
I don't think so. So that's probably a whole other thing is fixing.
That's a problem. The other thing we'll probably want to check is the Arduino power supply. Use battery power variant.
Okay. Yeah, that is doable though. All right, I think that wraps it up. I'll see you in a week.
All right, later, man.
All right, bye, dude.